Hello, welcome to Summary Notes, episode number 3. In this video, or in the videos, I should say, we will be covering lessons 1.2a to lesson 1.2d. So I'm going to go ahead and start with lesson 1.2a. In this lesson, you needed to determine the solution using a graph. Now, if we think back to what we talked about during our math talks, I mentioned how last year, if you look at my equation down here, last year you got used to how to solve these equations using inverse operations. This year, we are going to work mostly and a lot with graphs. And so we need to understand not only what we learned last year in the 8th grade math curriculum with solving equations, and in this particular case with variables on both sides using inverse operations, but as well as solving the equations when we have a graph or a visual to look at. So in this lesson, it walked you through that for any equation where you have the variable, so x, if we see here, on both sides the equal sign, we can go ahead and split them into two functions. So I'm going to go ahead and highlight our equation just so we recognize where we started. So our equation is negative 2x plus 3 equals 1/2 x minus 5. So when I split that into two different functions, the first equation that I will get is y equals negative 2x plus 3. And I'm going to go ahead and take my green highlighter to go ahead and show that that's one of my equations, which I'll eventually highlight down here as well in my graph. The second equation that we get is y equals positive half x minus 5. And so I'm going to go ahead and highlight in my yellow highlighter that equation to show that that is a separate equation from the one that I previously got. So once I take my equation that has variables on both sides and I split them into two different functions, I can go ahead and graph using Desmos.com. And then as it says here for now. In the future, I'm going to expect that we recall what we learned last year in the 8th grade math curriculum to graph these, what we call linear equations. If you remember, if you can tell, these linear equations are set up in y equals mx plus b form. So it's pretty easy to graph these two equations, which I'm going to do here and not use Desmos. But for the time being, before we go over that a little bit more in depth in a future lesson, I will allow you to go ahead and use Desmos.com for like your practice problems and things like that. So with that being said, I'm going to go ahead and graph the first equation. So I know that in y equals mx plus b, 3 is my y-intercept. So that is going to be 0, 3, which is a point on my line. And I see that my m, or my slope, is negative 2. So I'm going to start at my starting point of my y-intercept, and I'm going to go down 2 units and to the right 1, down 2 units and to the right 1, down 2, right 1. Now the reverse way of that is up 2, left 1, or up 2, left 1 again. And so with that being said, again, this should have been a review from last year, and we'll cover that more in depth later. But I can go ahead and take my ruler and connect these coordinate points and form a straight linear line. And to match the colors above, I'm going to go ahead and highlight this line in green. Notice how I try my best to extend my line all the way through the graph just so I could get a good visual as to where this line will continue going. Because I had a negative slope, it's important that I recognize that my line is going in the negative direction or has a negative correlation. So for my other function then, I know that my b value, which is my y-intercept, is negative 5. So 0, negative 5 is right down here. So that's my starting point. And then because I have a slope of a positive 1/2, I'm going to go ahead and go up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. And again, the reverse way would be down 1, left 2, down 1, left 2. And I'm just going to switch my paper around a little bit so I can take my ruler and go ahead and draw my straight line through here. For some reason, this looks a little off because I made down 1, 2, down 1. Oh, I made a mistake on that point. Ignore that point down there, I guess. All right, so even I make mistakes a lot. Okay, so I'm going to take my yellow highlighter and highlight that linear line. So now what I have is a nice visual, but what's difficult with this equation is it's kind of hard to see from my visual where my two lines exactly meet. So I'm going to come back to that in a little bit. However, what we can tell now is that because I have a graph here, I can determine whether this graph has one solution, no solution, or infinitely many. If my graph has one solution, that means my two linear lines will meet at one point, and that point is going to be x comma y. So I will have an x value and a y value, which we can kind of see a little bit on my graph here, where these two lines meet. If my lines end up being parallel to one another, so I'm going to write in the word parallel. If my lines end up being parallel, then that means they have no solution. And hopefully you can tell this because if you have two parallel lines, they are never ever going to touch or cross, so therefore they can't have a solution. Finally, if my lines end up actually being the same line, so what I tried to do here is one of my linear lines has an arrow on the ends, and then my other linear line, which ends up being the same one, I just put arrows kind of in between to show you that there's two lines here, but they end up being the same line. And when that happens, that means you have infinitely many solutions because any coordinate point along these two lines is a solution. So these would be your three options. So in this case, when I look at my picture, it's going to be one solution. However, if you can tell from your graph, my one solution does not occur at a whole number coordinate point. So what's good then is you can rely on what you learned last year in 8th grade math to go ahead and solve this equation with the variables on both sides. So I'm going to go up to the space above here, and I'm going to go ahead and do that. So my equation is negative 2x plus 3 equals 1/2 x minus 5. So with that then, what I'm going to need to do is make sure I get my variables all on one side of my equation. So what I'm going to do is I'm going to add 2x on both sides of my equal sign. And again, like I showed in our math talk, you can put the line down the middle of the equal sign. When I do that, on the left-hand side, I'm left with a positive 3 equals 1/2 plus 2 is going to be 2.5x. And then I copy the minus 5. Now my variables are all on one side. They're all combined. So I need to make sure all of my constants or my numbers are on the other side. So here I notice I'm subtracting 5. So the opposite of that is adding 5 on both sides. And when I add 5 on both sides, on the left-hand side of the equal sign, I get 8 equals 2.5 times x. Because it's negative 5 and positive 5 cancel out or give me 0. So the last step then in getting x by itself is taking the opposite of multiplication because 2.5 is being multiplied by x. So the opposite is dividing both sides by 2.5. So my answer then, when I take 8 and I divide it by 2.5, I find out is 3.2. So this kind of proves the fact, and I'm just going to circle this in here. This proves the fact that my answer to this problem, or my x value here, is not an exact whole number. So what I need to understand then is part of my coordinate point is 3.2. Therefore, to find the y of my coordinate point, because remember this is a one solution problem, to find the y value then, what's nice is I have two different equations here that I can use. So what I can do is I can take 3.2 and plug it in for any one of these x's, do the math using order of operations, and find my y. So I'm going to go ahead and use y equals negative 2x plus 3. And again, trying to use all the space that I can. Sorry, it's getting kind of confusing here. But I'm going to have y equals, copy the negative 2 from that equation, and then instead of x, I want to see what y is going to be when x is 3.2. And then I'm going to finish by adding the 3. So now what I will go ahead and do is go ahead and figure out this solution.